understanding the easy concept of projectile motion and 2D motion. Before starting the lecture, click on the subscribe button and get access to our 100 of unique and simple lectures for free. Firstly, let me teach you the vertical motion, which will make things super easy. For example, consider a ball present on the surface of the earth. Now you throw this ball in upward direction. Let the initial velocity of this ball is 10 meters per second. Here, let me discuss the upward motion of this ball. The first concept is that the initial velocity of this ball is maximum because when you throw the ball, you exert maximum force. The second concept is that the velocity decreases with the passage of time as this ball gains height. It is because of the air resistance and gravity. The third concept is that velocity becomes zero at a maximum height. Now the ball will fall down. Here, let me also discuss the downward motion of the ball. We know that the velocity of the ball at maximum height is zero. So in the case of downward motion, the first concept is that the initial velocity of the ball is zero. The second concept is that velocity of the ball increases as it falls down. It is because of the downward force of gravity. The third concept is that the velocity of the ball is maximum just before hitting the ground. For example, its velocity may be 10 meters per second. Therefore, remember that in vertical motion like upward motion, the initial velocity of the ball is maximum, but it decreases and becomes zero at maximum height. While in vertical motion like downward motion, the initial velocity of the ball is zero, but this velocity increases and becomes maximum just before hitting the ground. Now you must also learn the constant velocity in linear motion. Consider a ball present on the surface of a ground. When you kick this ball, it starts moving. Let the initial velocity of this ball is 48 meters per second. The ball covers some distance and finally it stops. This ball stops due to frictional forces like ground friction and air resistance. Now consider an ideal case. If we neglect the air friction and the ground friction, does the ball stops? The answer is no. No frictional forces mean that the ball will move with 48 meters per second at each and every point forever. It is an ideal case which is not possible in real life, but we study it only in physics. Therefore, we say that this ball is moving with constant velocity. Thus, remember that in absence of frictional forces, object moves with constant velocity. Now we can easily understand the projectile motion. Consider a ball. Let you kick this ball and it starts moving. We can see that the ball moves in parabolic path. I am interested to analyze the motion of the ball at this point. Initially, the ball is present here. Horizontally, it has moved to this point. But the ball is not present here. It is present vertically at this point. With respect to its initial position, we say that the ball is moving in horizontal direction as well as in vertical direction. Let me repeat it. The ball is moving in horizontal direction as well as in vertical direction. In physics, such type of motion is called 2D motion because an object moves in x direction as well as in y direction. Therefore, we say that the projectile motion is 2D motion. Now consider that the initial velocity of the ball is u is equal to 50 meters per second. Let the motion of the ball forms 20-degree angle with x-axis. What about the horizontal velocity ux and vertical velocity uy? Well, we know that ux is equal to u cos theta and uy is equal to u sin theta. The value of u is equal to 50 and that of theta is equal to 20. We get round about 47 meters per second. Thus, the initial velocity of the ball in x direction is ux is equal to 47 meters per second. Similarly, in the case of uy, put the value of u and theta. we get uy is equal to 17 meter per second. Thus, the initial velocity of the ball in y direction is uy is equal to 17 meter per second. Now listen carefully. The ball is moving in the air. The ball experiences two types of forces. For example, at this point, the ball experiences downward force of gravity and air resistance in this direction. At this point, the ball experiences force of gravity and air resistance. At this point, the ball experiences force of gravity and air resistance. As in ideal case, I neglect the air resistance on the ball at this point. I also neglect air resistance at this point, and I again neglect air resistance at this point. Let me ask you, how many forces are acting on the ball? Well, the answer is one. Only one force, the downward force of gravity, is acting on the ball. Therefore, note it down that only gravity acts on projectile. It means that there is no horizontal force acting on the ball. Thus, the initial velocity of the ball along x-axis would be 47 meter per second at each and every point. We say that the ball moves with constant velocity in x-axis direction. It is because no force is acting along x-axis. Now, what about the velocity of the ball in vertical direction? Well, the initial velocity of the ball in y direction is 17 meter per second. But as the ball gains height, its velocity decreases with the passage of time. For example, at this point is 9 meter per second, at this point is 5 meter per second, and finally, the velocity of the ball becomes 0. If you do not understand that y velocity of the ball decreases, then it is because ball wants to move in upward direction, but the gravity is pulling it in downward direction and thereby decreasing its velocity. Until now, we have learned that in projectile motion, an object like ball moves with constant initial velocity along horizontal direction or x-axis, while the velocity of the ball in vertical direction or y-axis decreases with the passage of time. Now let me analyze the motion of the projectile or the ball at each and every point, which will further strong your concepts. For example, at this point, the vertical motion of the ball is 5 meter per second and its horizontal motion is 47 meter per second. At maximum height, the vertical motion of the ball becomes 0, but the horizontal motion of the ball is still 47 meter per second. Remember that at maximum height, the motion of the ball is not 0 because the ball still moves with 47 meter per second in horizontal direction. Only the y component or vertical component of motion is 0. Now the ball will start falling down. At this point, the vertical velocity of the ball is negative 5 meter per second and its horizontal velocity is 47 meter per second. And at this point, the vertical velocity of the ball is negative 17 meter per second and its horizontal velocity is 47 meter per second. Remember that negative sign doesn't indicate the smaller value. It only indicates the opposite direction of the ball. Thus, we can analyze that as the ball moves upward, its velocity decreases with the passage of time in vertical direction, but its velocity in horizontal direction remains constant. At maximum height, the y component of the velocity is 0 but not the x component. Secondly, when the ball falls down, its vertical motion increases with the passage of time, but its horizontal motion again remains constant. To conclude the horizontal motion and vertical motion of the ball or projectile, we learn that the initial velocity of the ball ux is equal to u cos theta, like ux is equal to 47 meter per second, while the initial velocity of the ball in y direction is uy is equal to u sin theta, like uy is equal to 17 meter per second. Secondly, the velocity of the projectile remains constant along x-axis. According to Newton's law, when velocity is constant, net force in x direction is 0 and acceleration in x direction is also 0. In the case of vertical motion, firstly, velocity decreases. Secondly, at maximum height, velocity becomes 0. Thirdly, velocity increases. Hence, velocity is not constant in vertical direction, so the ball or the projectile experiences the net force of gravity in y direction. Therefore, it has gravitational acceleration -g in vertical direction. I hope that you have understood the concept of projectile motion.